In this video, I'm going to show you how to use the cosine rule to find missing lengths and missing angles in non-right-angled triangles. The cosine rule is a squared plus b equals b squared plus c squared minus 2bc cos a. There are other versions of this formula which make b squared or c squared the subject, but I prefer to just remember one version of the formula, and then I can label my triangle appropriately so that I can use the formula in this form. So my first example, I want to find a length in a triangle, and I'm given already two lengths and the angle which is opposite the length that I want to find. Now, in the formula, the length that I want to find is a squared. So I'm going to start by calling that side XA, and then the angle A is the angle which is opposite the length A. After I've done that, it doesn't matter which sides or which angles I call B and C. So let's call 5 the small b, and let's call 3 the small c. And then the angle B is opposite the length B, and the angle C is opposite the length C. Notice that I'm using small letters for my lengths and capitals for my angles. Okay, now that I've labelled my triangle, making sure that A is the length that is unknown and the angle A is opposite, I can substitute into the formula. So A squared, that means x squared equals B squared, that's 5, so 5 squared, plus C squared, so that's 3 squared, minus, just make sure that's minus 2 times b, which is 5, times c, which is 3, times cosine of the angle A, which is 85. Okay, now this is quite simple actually. I can just stick it straight into my calculator. I don't need to do any simplifying or rearranging. I just need to make sure that my calculator is in degree mode because my angle's in degrees. If I stick that into my calculator, I get x squared equals 31.385 and so on. I've not rounded this yet. And to find x, then I just need to take the square root of 31.385 and so on. In my calculator, I'll just write square root of the answer so that I'm getting as accurate a decimal as possible here. So that gives me approximately 5.60 centimeters, and I've rounded there to 3 significant figures. So in this first example, finding a length, I just make sure that the length I'm looking for is called small letter A, and I know the angle opposite to it, which is capital A, and then I can substitute into the formula. In this second example over here, I'm looking for an angle. Okay, so this time I'm going to call the angle that I want to find capital A. And remember that the length which is opposite that angle is my small letter A. And then my other angles are B and C, doesn't matter which way around. And 8 centimeters will be small b because it's opposite angle B. 3 centimeters will be small c because it's opposite angle C. Now I'm going to substitute into my formula again, but we'll see that I have to do some rearranging to solve this problem. It's not quite as quick and straightforward. So A is 6, so that's 6 squared equals B squared, that's 8 squared, plus C squared, so that's 3 squared, minus 2 times B, which is 8, times C, which is 3, times cosine of y. Okay, and I don't know why, that's what I want to find out. Now, I would say the best way to go about this now is to simplify as much as possible and then rearrange to make cos y the subject, and then I can finally find y. So 6 squared is 36, and then 8 squared is 64, plus 3 squared, which is 9, that's going to give me 73, minus 2 times 8 times 3, which is 48, cos y. Okay, now I can subtract 73 from both sides. So 36 minus 73 is negative 37. So negative 37 equals negative 48 cos y. Now I need to divide both sides by negative 48 to make cos y the subject. So negative 37 over negative 48 equals cosine of y. I've got a negative divided by a negative there, so that will give me a positive fraction. So let me write underneath cos y equals 37 over 48. I could also work out 37 over 48 as a decimal if I want to. I'd prefer to work with a fraction, it's tidier. The last step then is I need to find y. To find y, I need to do the inverse of cosine. So y equals cos to the minus 1 of 37 over 48. And if I plug that into my calculator, making sure that I am in degree mode and not radian mode, because I've got my angle in degrees, I want my angle in degrees, I should get approximately 39.6 degrees. And I've rounded there to 1 decimal place. If you are taking GCSE or IGCSE, then you are asked to round angles to 1 decimal place and lengths to 3 significant figures. Okay, so just to recap, when we were finding a length, we labelled the length we were looking for A and the opposite angle capital A. And when we were looking for an angle, we labelled that angle capital A and the opposite length small letter a. For the length, we just had to plug into the formula, not forgetting to square root at the end. To find an angle, however, we needed to do some rearranging to make finally y the angle the subject. Now, there is also a formula for finding an angle, which is found by rearranging the cosine rule. You can look that up and you can use it if you prefer to memorize formulas. Personally, I prefer to be more confident rearranging equations to find my solution.